Joining us today is Dr. Hideo Hosono, a professor at the Tokyo Institute of Technology. Dr. Hosono, thanks for joining us, and a big congratulations. You're the recipient of the Materials Research Society's highest honor, the von Hippel Award. Now, your citation reads, "For the discovery of high TC iron-based superconductors, creation of transparent oxide semiconductors, and inorganic electrides." Tell me a little bit about your work.
Okay, so that, when I was an undergraduate student, so amorphous hydrogenated silicon was created. So that now it's display industry, market size is grown to $100 billion. So the display, each display is driven by amorphous hydrogenated silicon. Okay, so my dream was to create a new semiconductor which exceeds the amorphous hydrogenated silicon. So one of the material which is now used to drive OLED is our oxide semiconductors. This is one invention. Mm-hmm. The second is also back to my young age, so that almost 1986. Okay, at the time that cuprate superconductor was discovered. Okay, as cuprate superconductors is discovered by George Bedros and Alex Mueller. Mm. Yeah, it's a big discovery. Yeah. Many people join at the same subject, but I could not join because I have no idea to exceed such a discovery. But in future, one of my dream is to create new superconductors comparable to cuprate superconductor. So the iron was people believe that the iron is the worst element to induce the superconductivity because the iron has a large magnetic moment. Magnetism and the superconductivity compete with each other. Okay. So, but now, as iron-based superconductor become a huge continent comparable to cuprate superconductors.
Now, you mentioned this just a few minutes ago. One of the results of your work is large-screen OLED TVs. Yeah. What does OLED stand for?
So the OLED means that the organic light-emitting diode. So the emitting material is organic semiconductors, not inorganic.
And does that help create the large screens we're starting to see, 60, 70, 80 inches?
Yeah.
How is that?
So that OLED is very easy to deposit. Okay. The problem is OLED luminous intensity is proportional by the current. LCD is just driven by voltage. So that to realize a large size OLED TV, the high mobility transistor is absolutely needed. So that currently used amorphous hydrogenated silicon and cannot meet the requirement. So at the time, our oxide TFT, so the people call the IGZO, indium gallium zinc oxide TFT, just meets these applications.
And speaking about the application, when you were doing this research, did you realize the application would be television? How did that come about?
Yeah, so I started this work in 1994. At the time, of course, I cannot see that.
No idea.
No idea. But the material research is just a curiosity, not application oriented in my case.
Very good. Dr. Hideo Hosono, congratulations on winning the von Hippel again, and it's good to speak to you.
Thank you.